There's one more thing that I want to cover about units, and I don't really want to call this advanced per se. You're absolutely capable of doing this, but it's probably something you haven't seen before, and it's a little more challenging to do. So the first thing to know is that we have this way of writing specifically the units of a quantity. So for instance, if I have my variable x, which is some sort of length, by putting it in square brackets, I'm talking about its units in particular. So the units of x, which is a length, in this case I could say are meters. The units of v, a speed, are meters per second. The units of a, an acceleration, are meters per second squared. People will frequently talk about dimensions in a similar way, where we would say the dimensions of x is a length, the dimensions of v, speed, is a length divided by time, and so on. But instead of worrying about dimensions, it's okay if we just talk about units as a representative of the dimensions. So what's important here to see is that when you look at the units in an equation, and therefore in the values that you might be plugging into the equation, that it actually works out that you're only adding things together that have the same units. So I have an equation here. It's the kinematics equation for constant acceleration in one dimension. And if I just say, what are the units of x, my quantity on the left? Well, those are meters. I have a different x on the right, which is also meters. My speed, meters per second. My time of seconds. My 1/2 I don't worry about. It's just a numerical value without any units whatsoever, so I don't write anything for that. Acceleration was meter per second squared. And then time squared will have units of seconds squared. So now look what happens. We have meters equals meters plus, here I have meters divided by seconds times seconds, so those cancel. So this becomes meters. I then have meters over seconds squared times seconds squared. These again cancel. I'm left with meters. So the units of this equation actually work out to be meters equals meters plus meters plus meters. That absolutely works. This is fine. So this is something important to think about, that if you wanted to just plug values into this equation, that's why your speed that you plug in must be in meters per second. If you know your speed in kilometers per hour, you must do the conversion between just plugging it in. So please be careful with this, but use this as a technique to check your work, which will help you find when you've made any mistakes. So I want to just summarize a little bit. Make sure that you're putting units on your numerical quantities. Again, a variable doesn't need to have units written after it, since the units are actually really inside the variable itself. You should be using SI units in my class unless otherwise specified. You might occasionally be asked to find a speed and convert it to kilometers or miles per hour, simply for the sake of having a better feeling for it. Please make sure that you're converting units carefully. I know that some students have seen this many years ago and you think that you can do it in your head, but people start to make mistakes, especially as we get to more complicated units in here. So please write it out and use that technique of making a ratio of equivalent values, which is equal to 1. Please always check your work by looking for values that are reasonable, and you can estimate. If you're not really good at SI units, you can look back at that chart that I gave you. And please check your work by ensuring that your units actually are of the correct quantities and that you can add them all together.